Question number 20. In the 18th century, Cavendish carried out the first experiment to determine the gravitational constant G. The experiment used two lead spears. A physicist planned to investigate the gravitational force using lead spears identical to the ones used in Cavendish's original experiment. One of the spears had a diameter of 30.5 centimeter and a mass of 158 kilogram. Second spear had a diameter of 2.5 centimeter and a mass of 0.73 kilogram. The minimum force that could be measured by the physicist was 50 micronewton. Deduce whether the physicist could be able to measure the gravitational force between the two spears. So this question we can do in two different ways. One, using this, you try to calculate what is the minimum, because the minimum force that this physicist can measure is 50 micronewton, right? So that means for achieving this, what is actually the distance required, you can calculate, and then you compare with the existing scenario, and then you can make a comparison. So like that is the method I'm planning to approach apply here. So this is the first spear, and then next one is this second spear. So we are actually measuring this force between this the distance between the centers is actually the separation between these two masses. So first radius is 30.5 diameter. So therefore radius of first one is 30.5 divided by 2. So 15.25. The next is 2.5 divided by 2. This is 1.25 centimeter. The mass of this is 158 kilogram. And this is 0.73 kilogram. So we know the basic equation for finding the force between this G capital M1 into M2 divided by R square. So the minimum force they can measure using this is 50 micronewton. So 50 into 10 to the power of minus 6, because micro is 10 to the power of minus 6, is equal to the value of G is 6.67 into 10 to the power of minus 11 into first mass is 158. The next is 0.73 divided by R square. So could you please help me to figure it out what is the value of R square? R square is 6.67 into 10 to the power of minus 11 into 158 into 0.73 by 50 times 10 to the power of minus 6. So from this, you can take the value of R by taking the square root of that answer. 6.67 into 10 to the power of minus 11 into 158 multiplied by 0.73 by 50 times 10 to the power of minus 6. So if you are calculating the minimum force that we can measure is 50 micronewton. Therefore, the maximum separation for this should be 0.012 meter. But in actual case, what is the separation here? In the real case, what is the separation? 15.25 plus 1.25 centimeter. 15.25 plus 1.25 centimeter. That is 16.5 centimeter. That means if you want to convert into meters, that is 0.165. So the maximum distance, so we can make a conclusion. The maximum distance to give minimum force 50 micronewton is 0.012 meter. 0.12 meter. and 0.012 meter is less than the actual distance 0.165. So what is the conclusion? Deduce whether physicists would be able to measure the gravitational force between the two spheres or not. So what is your conclusion? We can say that we can make a conclusion that what is the conclusion? It can't be measured. It can't be measured. So this is one approach. Or you can do in another way. That means using this existing separation, you can calculate what is actually the force. The exact force between this 15 kilogram and 0.73 kilogram, you can calculate that force. So obviously, if you're calculating that force is less than 50 micronewton. So it's not possible to, if you're calculating, you will get that will be less than 50 micronewton. So it's not possible to measure that value because minimum force they can measure is 50 micronewton. So the value we are obtaining, the force we are obtaining here is less than 50. So it's not possible to measure. Okay. Okay. Experiments to determine G have successfully carried out using large masses. In 2021, the physicists at the University of Vienna carried out an experiment to determine G using gold spheres with masses of less than 100 milligram. They obtained a value of G as 6.04 10 raised to minus 11 meter cube per kilogram per second square. Show that meter cube kilogram raised to minus 1 second raised to minus 2 is a correct unit of G. So what is the basic equation for F? G m1 m2 by r square. So from this you can make G the subject. So G is equal to Fr square by m1 m2. So then what is the force unit for force? It is Newton. Distance square, that is meter square, kilogram square. Now Newton means it's force into Newton means it is actually the force. It means force in mass into acceleration. So that means it is kilogram meter per second square. So this Newton we can replace it as kilogram meter per second square multiplied by meter square by kilogram square. One of the kilogram and kilogram got cancels. Meter into meter is meter cube divided by second square kilogram. So what is the final answer? We got the value for G. It is meter cube divided by kilogram second square. So if you are taking kilogram and second square to the numerator, meter cube, kilogram raised to minus 1, second raised to minus 2. That is actually the correct unit. Hence, short. Hope you got that idea. Move to second question of B part. The physicists concluded that their value of G was within the reasonable agreement within the standard value of G. Evaluate the validity of their conclusion. So first of all, you calculate what is the percentage change. How will you find the percentage change? The 6.67 in 10 raised to minus 11 minus the actual value was 6.04 into 10 raised to minus 11 divided by 6.67 into 10 raised to minus 11. So this percentage change will help us to know the deviation into 100. So if you are substituting this, you will get nearly 9.4 percentage deviation, the percentage change or percentage difference. So after finding this percentage difference, see, the physicists concluded that their value of G was within the reasonable agreement with the standard value of G. Since the percentage change is less than 10 percentage, we can conclude that this is in reasonable agreement. That's up to you. Like if you want to state it as like since we have 9.4% change is there, that is not within the reasonable agreement, that also you can say. That's up to you. That's your mindset. You can explain according to that. So whatever be the explanation you are making or you are commenting, will get 1 mark for that. A reasonable explanation will give 1 mark, or that will help you to bag 1 mark. So if you're calculating the percentage change, you will get 1 mark. Then the appropriate comment based on this percentage difference, that will also help you to get 1 mark. Clear? So that is the idea about this part.